Welcome back everyone to the second of 5 workshops we'll be hosting. So in the first workshop last week, what we did was we created a project, we learned the basics of the Unity user interface, and we created a background for our game, and we also added a player object. So what we'll do today is we're gonna get into making the player object behave the way that we want. And yeah, so we're gonna have like movement, and we're gonna make the player sort of rotate to the direction to the position of our mouse cursor on the screen. So yeah, let's get into it. So, well, the first thing that we want to do is we want to make our player move depending on like what input that we have given to the game. So there are many ways to move an object in Unity. You can move it like with the transform component, like modify the X and the Y axis, just like that. But what we're gonna do today is we're gonna move our player object using physics. Alright, so the first thing we need to do is to tell Unity that we want physics on our player object. And the way that we're gonna do that is through a component that is called Rigidbody 2D. So if I select the player object, and in the inspector, a quick reminder from last week's workshop, we have objects and we have components. So an object is an entity in your game. It can be anything. In this case, we have our camera, we have our background, and we have our player. And each object have components and these components define what are the behaviors of the object. So here in our player object, we have a sprite renderer component. So this component is telling Unity to render this plane right here, basically. So we want to add another component to our player object to tell Unity that we want physics applied to this object. So there's this add component button right here. You can click it, and it will give you this interface where the different components are grouped into categories. So we have like physics 2D, animation, audio, etc. And there's also a search bar here. So if you already know what component you want to add to the object, you can just search. So what I can do is I can go into physics 2D and find something called Rigidbody 2D. And if I just click on that, and it adds the component to our object. If I want to remove a component, I can click on this 3 dots next to the right of the name and remove the component, just like that. So I'm going to add it again. So add a component. This time I already know exactly what component I want to add. So I'm just going to search for it. So Rigidbody, and we have 2 variations here, Rigidbody and Rigidbody 2D. So Rigidbody is for the 3D version of our objects. So if you're making a 3D game and you want to apply physics to that 3D objects, then you're going to add Rigidbody. But since we're dealing with a 2D game, we're going to add a Rigidbody 2D. So we click that, and we have a Rigidbody component added to our player. And now that we have told Unity to use physics in our player, what we can see here is that there are many different attributes that is tied to the Rigidbody component, just like we do with the sprite renderer. And If we just going to play our game real quick, so click play, we're gonna see that our player will just kind of fall down due to the gravity. Yeah, just like that. And we want physics applied to our player object here, but we don't want gravity applied to it, right? We want to move our player around using physics, but we don't want our player to fall down from the sky due to gravity. So what we can do here is there's this attribute called gravity scale, and what we can do is it is currently 1, and we can set it to a value between 0 and 1, and we can set it to 0 and hit enter. And now if we go and play our game, we can see that our player will no longer fall from the sky due to gravity, because we set our gravity scale to 0. It's basically tell Unity that we don't want gravity applied to our player object. And yeah, that is I believe that is the only attributes that we should be concerned with for now. So we added the Rigidbody. Now we'll get into the real stuff here. We have to actually tell Unity to move our player according to our input. So to do that, we're going to have to create a script, and we're going to have to code that script accordingly. So a quick reminder, a script is basically a special component that we can attach to our game objects, and in that component we can define the behaviors that we specifically want from that object. So like similar to a Rigidbody component that add physics to our object, our scripts also add behaviors to our object, but we have to define those behaviors ourselves. Alright, so the first thing we need to do to get started with coding is create a script in the project view. And here we have like 4 different folders. What I'm going to do is I'm going to create a new folder, and so just right click on the project panel, create and folder, and this folder is going to be called scripts, and it is where we will store all of our scripts inside it. And you don't have to do this, like you can just store our scripts in the fonts folder or the scenes folder or just our assets folder, but it is generally like a good practice to have our file structure organized by categories. So that's why I'm creating a scripts folder, and in here what we can do is create a new script. So I'm inside the scripts folder, and I'm going to right click, create, and this time instead of creating a new folder, I'm going to create a new C# script. So I'm going to click this, and it's giving me the option to name our script here, and this is actually quite important, as we'll see in a second. So in here it's giving me the option to name our script, so I'm just going to call it player movement, since this script will control the movement of our player. So it's created a script, and you can see down here that it is actually compiling the script. So the way that scripting works in Unity is that every time a change is made to a script, and you save that change in like whatever text editor that you want, and you go back into the Unity editor, the Unity will recompile your scripts automatically and then update accordingly. So we have the player movement script, we have a player object, and we can just add the player movement script to our player object. And we can do that very easily by dragging the player movement script from our project and dropping it onto the inspector of our player object. So I drag, and if I just drop it, we see that we have a new component added, and that component is called player movement. We can also, let me just remove this, collapse. So okay, we can also go add component, and we can search for our player movement, just like that. And so yeah, so now we have the script created, we have our player movement script attached to our player object. The next thing to do is to edit this script and make it perform the actions that we want. So in last week's workshop, I mentioned that you can use any text editor with Unity because you're just editing the file itself. So if I show this in Explorer scripts here, we have our player movement. It is a C# script, so the file extension is .cs, and you can use any text editor to edit the script. So if I right click here and edit, it will bring up Notepad, and you can just use Notepad to edit the script. You know, I would advise against it, but you can if you want to. I also mentioned that I will be using Visual Studio Code. I already opened it, and I already opened the folder, our project folder. So we have assets, scripts, and player movement script. So yeah, so this is how I'll be like editing our script in these workshops. If you're using a different text editor, Visual Studio or Sublime or whatever, you can set that to be the default text editor in Unity by going to Edit, Preferences, and in the External Tools tab, we can have this external script editor, and I set it to Visual Studio Code. And yeah, if you click this, it should, if you have like many different editors installed, you have like the options to, or you can even browse for the actual executable of the code editor. And to open the script, you can do that right inside of Unity. If you just double click on the script itself, it should bring up the text editor. You can also, in the project panel, you can also right click and open C# project. That will do the same thing. It will open your whatever text editor, and will open your project. So let's look at our newly created script. We have some using statements, we have a class, and we have some methods. So for now, let's not worry about the using statements. What I will worry about is the class. So earlier I told you that the naming process when you create a new script is important. So I created the player movement script and I named it player movement. And it is important because here we have a class with the same name, player movement. So that's what Unity is going to do when you create a new script, it's going to add some basic code that you're mostly going to need in order to make the script works with Unity, so the using statements and the class. And it is important that the class name is the same as the file name. So if this is player movement, the class name has to also be called player movement. So if I go into Unity here and if I create a C# script and I don't name it right away, I just click enter, it's going to create a script named new behavior script, and the class name of that new behavior script is also new behavior script. And now we're gonna have to, now if we want to rename, so I created a new script, so it has to recompile the project to update. If you want to rename this to player movement, we're going to also have to rename this new behavior script to player movement. And this is something that a lot of people sort of forget about when they rename their scripts. They always forget to rename the actual class name itself, and it leads to a lot of errors. So yeah, it is something to keep in mind. If you want to rename your script, also rename the class name of your script. And it is ideally that when you create a script, you should name it whatever you want right then and there. All right. So let's get back into our player movement script. We see that this class has it inherits from mono behavior, and this is similar to the using statements here. It is something that is required for a script to work within the context of Unity. So it's not something that we're going to worry about like right now, but just keep in mind that you're going to need it to work for the script to work with Unity. And we see that Unity also added 2 methods by default here, functions. I just call them methods because it's in a class, so you can call them functions as well. We have start and update, and they have some comments here to tell us what are these functions. So they say that start is called before the first frame update, and update is called once per frame. So what does that mean? Well, when we play our game, what it's going to do is first it's going to call start. So whatever we put inside of these 2 curly braces is going to be called, and then every time a new frame is rendered on our screen, they're going to call the update method. So whatever code that we have between our curly braces in the update will be called every single frame. And these 2 methods are called Unity event functions, and they are something that Unity will call, the Unity editor will call when you run your game. So you don't have to call these 2 methods. Like, you don't have to go and say start, because Unity will call it for you. And yeah, so these 2, so it is actually important that when you create a new function or a new method, that you don't name your method start or update or other Unity event functions, so that Unity doesn't get confused and like call the wrong thing. So yeah, that is also one thing to keep in mind. Do not create a function that is named the same as a Unity event function. Alright, so we have our 2 methods here, start and update. So let's get back into the purpose of this script in the first place, which is moving our player object. So fundamental question, how do we move it? Well, the sort of universal way of working with Unity scripts is that you're going to make a reference to either an object or a component, and you're going to manipulate the attributes of that component, or we can call a function that is tied to that component. And what I mean by that is, from this player movement script, I can make a reference to our Rigidbody 2D and say I want to set the gravity scale to 1. I can do that through script. So to demonstrate, I'm going to go into my player movement script, and to make a reference, I'm outside of the start function here. To make a reference, we want to reference our Rigidbody 2D, right? So I'm just gonna say Rigidbody 2D, and I'm just gonna call it RB, or Rigidbody 2D. It auto completes, fine. And now, say when we start a game, I want to set the gravity scale to 1. Here in the start function, I can say Rigidbody 2D dot gravity scale equals 1. And okay, so you might have noticed that I put 1F here and not just 1, and this is because the F here is indicating to Unity that this value 1 is a float. So gravity scale, the property, the attribute is a float, so we have to indicate that we want that the value that we are setting it to is also a float. So if I save my script, file, save, or Control S, and I go back into Unity, you can see that Unity will recompile the code automatically, and it will be done. And if I play the game right now, nothing's going to happen. So if I play the game right now, I'm actually gonna get an error. So let us see an error. Yeah, so if we look at our console here, we can see that object reference not set to an instance of the object, so we get an error, and our player does not fall down from the sky as we would expect if we change the gravity scale to 1. So why is that? Well, here we say we want a reference to a Rigidbody 2D, and we want to set the gravity scale of that Rigidbody 2D to 1. But we didn't tell Unity what Rigidbody we're talking about, right? It can be any Rigidbody in the game. So what we have to do here is we have to say that this. So if we say that this is a public Rigidbody, right? So I added public Rigidbody in front of the reference here, and go back into Unity. Wait for it to recompile. Come on. Alright, so we select our player object and we look at the inspector. We see that now we have an attribute quite similar to the attributes up here that is asking for a Rigidbody 2D. So what we can do is, again, with like these sort of fields that have a circle next to it, you can click on the circle and it will pop up a selector, and you can select whatever that is in the selector list that you want. So we only have one here, which is our player. So if I select my player, I close this, and now the Rigidbody 2D will now reference our player Rigidbody 2D. And something that we can also do is, if I set this back to like none, we can also drag and drop. So if we drag our player onto this field here, you can see that is turning blue, which indicates that if I let go here, we can do the same thing and tell Unity that this Rigidbody 2D reference is referencing a player Rigidbody, which is up here. Right? If I want to reference an object that doesn't have a Rigidbody, like the camera, for example, like the camera doesn't have a Rigidbody 2D component. If I want to track the camera into here, you can see that it doesn't work because our camera doesn't have a Rigidbody 2D component. So yeah, it only works with our player because our player has a Rigidbody 2D component attached to it. So now we have Rigidbody and we reference our player. If we click play in our game now, we should see that the player will fall due to gravity, because if we select our player, we can see that the gravity scale is 1 here. So that indicates that our script worked and we successfully set the gravity scale to 1. Alright, so that is the basics of how to script with Unity. You reference a component and you manipulate that component. So the next thing that we want to do is, that's great, but we want to move our player itself, right? We don't want to set the gravity scale, alright? So there is a method in our Rigidbody component. So by Rigidbody, there's a method called move position. Right? And this method is going to take vector 2. So first of all, what is a vector 2? So a vector 2, if I delete this, if I create a public vector 2 here, and I call this test just to demonstrate, a vector 2 is basically, if you ever taken like geometry or algebra, we have like a coordinate system with like x and y. So a vector 2 is basically a value that holds 2 more values, an x and a y. So we created the test variable here. If I go back into Unity, I can see that my test variable has 2 values, which are x and y. So select our player, and you can see test, we have x and we have y. So that is vector 2 in Unity. It is a very important variable type in Unity. You see this used everywhere. You can also have like vector 3 for x, y, and z, but that is only for like 3D games, so 3-dimensional. Will not be using vector 3 a lot in our workshops because we're making a 2D game. So so that is the basics of vector 2. So I'm going to move this, and just like I said, we have a Rigidbody 2D, and we have a method called move position. So yeah, so we have a method called move position, and inside the brackets here we pass in a vector 2, and this vector 2 will represent what position we want to move our player to. So if I just create a vector 2 like here, to like a new position or something, I can instantiate this vector 2, so equals to new vector 2, and inside here I can put the x and the y values of whatever value that I want. So if I want my new position to be 3 by 3, right? And the x and y values of vector 2 type is also float, so I'm putting the f here to tell Unity that these values are float. So we have our vector 2 new position, have our rigid body move position, and what we can do now is we can put our new position here. And what this essentially does is that it's going to move our rigid body object. So the object that we have a rigid body component here, what it's going to do is going to move this object to this new position. So if I go back into Unity, and this move position is like a teleport thing, so the player won't like slowly move to that new position. The player will just automatically teleport to that position. So we have our player here, and if we play the game, we should see that our player will sort of move to the position, yeah, automatically. So we select our player, and we can check our position to be 3 and 3, so 3x and 3y, because here our new position is 3x and 3y. So yeah, so that is a way that you can move a rigid body object in Unity. Now the next thing we want, I'm just going to get rid of this. The next thing we want is, okay, so we know how to move an object, but we have to move that object according to our input, right? We want to press the arrow keys or the WASD keys and have our player react to the input that we want. We don't want our player to move automatically. So how exactly do we do like input checking in Unity? Well, what we can, so in Unity, how we check for inputs is, actually, if I go to our Unity editor here, and I go to project settings, you can go, if you don't have the project settings, you can, I think you can edit and project settings, so it's going to give you this window here. And on the left, if you click Input Manager, you see that we have axes, and this is a collection of predefined like input buttons that Unity have created for us, and we can add more or we can remove these axes as well. So I'll say we have a horizontal axis. So if I click this to expand, you can see that we have an axis named horizontal, a left, right button as negative and positive buttons, and we also have alternative, negative, and alternative positive buttons. So what exactly does that mean? Well, we can check. So basically, it's telling here if the player click the left button on their keyboard, this axis is going to be negative. So it's a value, right? The value of this axis is going to be negative. And if we click the right button on our keyboard, the right arrow button, the value of this axis is going to be positive. And it's saying like negative and positive. In reality it's like -1 and 1. So the value of the axis is always going to be -1. It's go between -1 and 1. So to test this, we can go into Unity and we say, so we can create like a value. So if I say float axis, or let's call it horizontal, right? And set it to input get axis. And in this axis, we going to pass in the name of our axis that we want to get. So here the name is horizontal. So in our script we want to get horizontal. Save that. So now that we have our horizontal sort of value, and that will be like between -1 and 1 according to our input. What we can do now is we can just print it onto the screen. So in Unity we can do that by say debug.log, and in here we can just log the horizontal. And what this does is, you see our console up here. So previously when we had an error with our player, we received the error message in our console window. Now when we play the game, the debug.log will also here will also print our horizontal value onto this console. So I'm just going to play the game here, and alright, so it's printing it every frame, and it's 0 because I'm not touching anything. If I hit left on my keyboard here, you can see that it's changed to -1. If I let go, it will go back to 0. If I click right, it will change to 1, back to 0. And I can also do that with the A and the D key, because we have them assigned as alternative keys. So do this. So because here we have left, right, we have alternative negative to A and alternative positive D. Right. So yeah, we have Unity read our input as horizontal, and here if we collapse this, we also have vertical axis, and this is the exact same thing, except it's the vertical axis, and instead of left to right we have up and down, and instead of A and D we have S and W. So we can also go in Unity here and we have float vertical and input get axis vertical, and yeah, now we have our horizontal and our vertical axis. To check it, we can just log it onto our screen. So debug log. So this time I want to log the vertical axis. So go back into Unity. Yeah, wait for it to recompile. Sorry for that. Yep, so we're back in Unity, and let's play it to test our vertical axis. So it's logging, same thing, and now it is 0, and if I hit up on my keyboard, it will move to 1. If I let go, back to 0, and down will be -1. So the exact same thing as our horizontal axis, except this time it is the vertical axis. So so we know how to move an object in Unity, right, using Rigidbody, or we know how to read our inputs in Unity using axis. Now we can put them all together and make our player move according to our input. So we know how to move our player using Rigidbody, and we know how to get our input using input.getAxis. Now we can put it all together and move our player object accordingly. So what I want now is I want to have a variable to store the velocity of my player. So I can create a float and call it velocity. Yeah, and it should be 10. So the next thing that we want is we want to have a sort of a vector2 to store our direction, like what direction is the input is we're inputting. So the direction is going to be of type vector2. So if I so up here I'm going to create a vector2 and call it current direction. And if we don't specify anything, Unity will default this vector2 to be 0 by 0. So yeah, and in our update, we want to check. So we have already checked for input horizontal and vertical. We can now just assign it to our direction. So we can say current direction equals to new vector2 as we did before, and in the x-axis is going to be our horizontal value. So I'm going to put horizontal, and in the y-axis is going to be our vertical values. So I'm going to put vertical here, and we have our direction. Alright, so we have checked the input for our direction. Now we want to move our player, right? We want to move our rigid body at this direction. So we do that. Well, as before, we can move the position of the rigid body. So rigid body 2D dot move position, and in here, remember the position, the vector2 position that we put in here is a value, and the player would just like move immediately to that value, right? And that's not what we want. We want our player to sort of move slowly at a direction. So here we can actually say rigid body 2D dot position, which will actually return the current position of our player here. And go back to our script, and we can add this with the current direction, right? So when we perform like an addition of two vector types, Unity will add the x values together and a y value together. So because here we have the rigid body position, which is a vector2, we have our current direction, which is also a vector2. So we add the two vector2 together. So it's going to add the x-axis and it's going to add the y-axis together. So And we also have velocity that we set up here. We can also multiply by the velocity. And just like in vector addition, when we multiply the vector, the x-axis also gets multiplied together and the y-axis also gets multiplied together. So what we're saying here is move to the current position plus the direction and velocity, right? So if we save our script, go back into Unity, wait for it to recompile. Yeah, so it's done. We can play it now. If I click play here, and you see that our player will move according to our script, but it will be very sort of wild, right? If I just click left and the player just like fly off the screen immediately, it was so fast, right? If I click right, left, right, so that was so fast, and it's not exactly like what we want from our player. And what you can do is you can go in here and modify the velocity to like a very small value, like 0.01 or something. But what we can do here is, so in addition to multiplying to the velocity, what we can also do is multiply by time dot delta time. And so what is time dot delta time? Well, it is the sort of time between the frames. So when we're playing a game, the new frames are continuously being rendered. So time dot delta time is the time it takes to render a frame, and this will give us like a very consistent player movement. So if I go back into Unity and I hit play, wait for it to enter play mode, and we can see that now when we can move our player using the arrow keys or the WASD keys. Very cool. Yeah, just like that. And if I let go, the player just stopped moving. So now we have a player movement script. And what I want to do now is, well, the script now works, but I want to extract this information into a separate function so that we can neatly organize everything. So I'm going to create a void, and I'm just going to go fly. And it's going to cut this, put it in the fly. And so in the update function, we just call fly, just like that. So we have a player now move according to our movement script. What we also want is, if I go to my game, let's see, GMU. All right. So what we also want is for the plane like object to rotate to our player, to our mouse cursor. So if the mouse is here, the plane should rotate to look at that mouse. I think we have, yeah. So we have a player here, and the player should sort of rotate to look at the mouse, and and change the rotation based on our mouse input, our mouse position. So, and we can do that very easily. So if I go into Unity here, and again, I'm going to create another function to organize my script. So I'm going to say void look at mouse. So the first thing that we need is the mouse position input, right? Right, so but we don't have any axis here that sets mouse position. Well, luckily, Unity have a method, a value inside of the input for us to check for the mouse position. So if I create a vector tool, because we have the mouse X and Y, and we have mouse position, and it's going to be equals to input dot mouse position, right? And right now, let's just log this onto our screen and see what value Unity will give us. So log mouse position, and we also have to call this function in the update. So look at mouse. Save that and go back into Unity again. Wait for it to recompile. And it's done recompiling. Let's play our game and take a look at our console to see what value Unity will give us based on our mouse position. So you can see that the values, so as I move my mouse, the values changed, right? But you can see that the values are very large, like 400, 800, 600, etc. And this is because Unity is returning the mouse position based on the resolution of our screen. So if you have like a 1080p monitor, so the value of the mouse X and Y will be between 0 and like 1080 or 1920, as I recall, the resolution. So, but what we want is we want the mouse position inside of the game world, right? We want a mouse position relative to our player position, right? So if our mouse is here, it should be like 2 by 2 or something, right? We don't want to be like 300 by 300. So we need to convert this mouse position, like the screen mouse position, to our world mouse position. And luckily again, Unity also have a function to do that. So instead of say input.mouse position, what I can say is camera.main.screen, let's say screen to world point, and in here it will be our mouse position, right? So input mouse position. So what I'm saying here is make a reference to our main camera, right? Camera.main, which is our main camera right here, right? So camera.main, and convert whatever the value that we put in here. So the camera will convert the position, which the value that we put in here is now our mouse position, and convert that from the screen position, the screen point as they say it, to the world point. So go back into Unity, see that it's done recompiling. Thank you. We play the game and take a look at our console. And yeah, so now that we see that the value looks right? The X value is about 6.5, which is correct. If we move, we also have, you can see that the values change. The Y value is about 0, which is correct. And so yeah, now we have a mouse position relative to the world and not relative to the screen. So now what we need is a direction for our player to look at. So I'm going to create a vector tool and call it look direction. So look direction. So what direction will our player look at? Because, well, we want the player to look at the mouse, right? And So we can get the direction from one object to another in Unity, right? So we have a player here. Say we have a player. Let's go to game view. So we have our player here, and we have our mouse here. What we want is a direction from our player to our mouse, right? A sort of linear x and y value that represents that direction, right? That's why it's called a vector. If you know the reference I'm making. Anyway, we have our direction. So what we can do is we can subtract the mouse. So we can say the mouse position, and we can subtract transform position, right? So what transform position means is that it is the position of my player, because the script is attached to a player. So transform position is the player's position, right? And what we also want is, because if we go to our Unity here, we see that the position has three values, x, y, and z. Here, the mouse position is a vector 2, look direction is a vector 2, but transform position is actually a vector 3. And if we save it and go into Unity, we can see that we get an error in our console view that it doesn't allow us to subtract a vector 2 from a vector 3. So we have to convert this vector 2 to a vector 3. And we can do that very easily by, in front of our transform position, just put the up pair of brackets and say vector 2. And now that we convert our transform position to a vector 2. So now that if we go back into Unity, we don't have any more errors. You see that the error should go away. Yeah, it does, right? But it's not done just yet, because so we have our mouse position and we have the current player position, and we subtract them, but that's not our direction just yet. Because say like we have 10 and then minus 2, so that should be like 8. And what we want from our direction is the magnitude of the vector should be 1, right? Because it's a direction vector, it's not like a length vector. So in Unity, there is a very neat sort of function, or not function, it's a value in the vector. So the look direction is a vector, right? And we minus, so we have mouse position minus transform position. We can also say dot normalize, and what normalize mean is, let's go back to my code. What normalized mean is that it's going to make this vector to have magnitude of 1, right? So if you've ever taken like algebra, you might understand it. So say if we have like a vector that's 0 and 1, so this is a vector that's already have the magnitude 1, it's not going to do anything. But if we have like 10 and 1, so it's going to normalize it. So this should be like, I don't know, like 0.9 and 0.1 or something. So that's what normalization means. It's just going to give us our direction. And so now let's just debug log our look direction and see what we get. So debug log look direction, everything looks good. Let's go back to Unity. Wait for it to recompile. A note on the recompile of Unity scripts is that you might have noticed that it's running like pretty slow for me today, and that is because I'm having like quite a lot of programs running at the same time. It should be a lot faster on your local machine if you're not like screen sharing and recording at the same time. So yeah, just a note. So if we go to our if we go to player game and look at the console, we can see that we have a direction, and the value is now, and the magnitude of a direction is now 1. So if I move my mouse, if I move it like right above the player, we see that the direction is 0 and 0x and 1 in the y-axis. So, and that is because the player their look direction should be up, so 0x and 1y. And now we have our direction. All we have to say now is for the player to look at this direction. So we want the player's up axis to be our look direction axis. So similar to our transform position, what we can say is transform dot up. And what this transform dot up mean is the upwards direction of our player object, of a transform. So it's currently like 0 and 1, so our player is looking up, right? So transform up, when we can modify this to be our look direction. And say that, go back into Unity. So again, let me recap. So we have our mouse position, we have our look direction, which is the subtraction of mouse position and the current player position. We normalize the vector and we set our transform up to be the direction, look direction. And if we hit play, we will now see that the player will look at our mouse. Yeah, just like that. You can see if I move my mouse around, the player will follow that. Yeah, that's exactly what we want. So that is our player sort of movement completed. What we will do now is so if you notice in the game that we prepared for the workshop, when the players sort of move around, there's this sort of particle effect that follows our player, and it gives a very sort of neat effect to improve the feel of the game. We also have, there's a little shadow here that reflects our player because, you know, we're like the plane is sort of high up on the ground, so we have a shadow there. So we can implement that very, very easily. So first, the shadow. What we can do is we can make the shadow a child object of our player. So what I can do here is just go to sprites, ships, and ship 0000 is our player. I can just drag and drop it onto our player to create a child object. So going to our scene view, we see nothing's changed because the position of the two objects are the same. If I move my shadow object out of the way, you can see here that we have this new plane, and we're going to do the same thing as we did for our player object, is set the sorting layer to 1 so that it's rendered above the background, and I'm going to set the position to about like -1 by -1, and I'm going to name this shadow, just like that, right? And what we want here is the shadow to be completely black, right? We're using the same sprite, but we want the color to be completely black. And what we can do is, in our color, click that, it gives me the color picker, and I'm just going to say black. And we have our shadow. Let's move the shadow down a little bit, -2. Yeah. That looks good. And we can also do is we want our shadow to be less like visible, and we can do the same thing to our background. We change the alpha value to be like 100, and there we go, we have our shadow. And the beauty of this is that the shadow is a child object of our player, so if we move our player, the shadow will follow our player, right? So if we move our player, I'm moving it in the scene view here, you see that the shadow sort of follow our player. And if I hover over like the little island that I have in the background, you see that there's this nice little effect here. It looks very real. But we also want, now if we play the game, we see that the shadow will indeed follow our player in the game as well. So yeah, and it will follow a player like the position, but the rotation is not correct, right? We don't want the because if we're rotating the player here, the shadow also rotates because it's a child object of our player, and we don't want that. We want our player to be fixated on one position only. So we can do that very easily through the script. So let's go into our player movement script again and make a reference to our shadow, and we want to make a reference to the transform of our shadow. So public transform shadow, just like that. And what we want to set is we want to set the shadow's position to be the player's position minus 1 on the x-axis and minus 2 on the y-axis, right? So let's go to our update. We can say shadow that position, and we want to be transform the position, and we want we want to minus a vector 2 from the position, right? So minus new vector 2, minus 1 and minus 2. And again, because we're doing operations with transform position, we have to convert it from a vector 3 to a vector 2. Save that and go back into Unity. Let's see. Yep, so waiting for it to reload, and it's done. And if we select our player here, go to the inspector, we can see that we have a new field, just shadow, and we can just drag and drop our shadow onto it. And because this is a transform, and every object in Unity has a transform component, you can also have like the camera here, because the camera also have the transform component, unlike our rigid body, which only our player has. So be careful with your drag and dropping. So put it on shadow and hit play, and we should see now that the shadow will position itself correctly, I think. Yeah. So what we see here is that the shadow is sort of like at the opposite direction of what we want, and this is because I made a mistake here. Should be plus, because if we do like minus of minus is plus, so it should be plus instead of minus. So save that, go back into Unity, and now it should work correctly. So the next thing that we want to add to our player is the particle trailing effect that we saw in the game. So we can do that by if you right click in the hierarchy, and so we have been creating sprites and tile maps so far. What we can do now is I want to go to effects and particle system. So if I click that, it's giving me the option to name. I'm just going to call it trail. And go to our scene view, we'll see the particle system here. So what are particle systems in Unity? Well, particle systems is sort of like an effect, to show the different like particles, if that makes sense. So if we have like a fire effect, that is a particle system. We have like smoking effect in Unity, that is also like particle systems. So yeah, it's a way to make special effects with individual particles in Unity, right? So I'm going to reposition here, -5, -5, and 0z. And yeah, I'm gonna so we have our particle system component, and you can see it is a huge component with a lot of fields, a lot of attributes, and and these attributes are kind of expand. So if you like expand external forces, you can have more attributes. So yeah, again, if you don't understand like what some of these mean, you can always go to the reference documentation by clicking the question mark button here. And frankly, I don't like know a lot of these what they mean either, but we should know like what matters, what we want to change here. So first thing is that we want the trailing effect to sort of play when our player moves, right? If our player is standing still, we don't want a particle system to display anything. We can do that in emission. So trail, emission, and instead of rate over time, I'm going to set rate over time to 0, and we see our particle system stops because there's no particle over time anymore. But if I set rate over distance to about 0.5, and now if we move our particle system, we see that it will start playing when we move it, and it stops playing the particle when we stop moving it. But we want the individual particles to be like trailing effects for our player, right? We don't want it to be moving up, or we don't want it to be moving with our particle. So first thing we can do is in simulation space here, we can say instead of local, set it to world. And now if we move it, we can see that the particle system, like the individual particle, doesn't move with the particle system. But it's also moving upwards a little bit, which is strange. So we can just set the speed of our particle to be 0. So here, under trail, we have start speed, and I'm going to set it to 0 here. And now when we move our particle, you see that it's more of a trailing effect, right? The individual particle doesn't move anymore. And we see that the lifetime of our individual particle is very sort of long, right? It takes a very long time for them to destroy. So I'm going to set the lifetime to 1, right? So instead of 5, we have 1, and now we have a much more nice looking trailing effect. What we want now is we want to, instead of display this like weird looking particle, we want to display a sprite of our choice. And we can do that right way at the bottom. So still we are in the inspector with our particle system selected. We have renderer here. And if we expand that, click to expand, we can see that the material is set to default particle system. And we don't want that, so what we're going to do is we're going to create our own material and assign the sprite to that material. So first thing first, how to create a material. It's the same way as we create anything in Unity. In the project panel, we create, first thing first, a folder to store our materials. So to have our projects better organized. So create a materials folder and create a material, and I'm just going to call it trail. And so here I've set the, so here we have the different sort of properties to our material. And let's see if we, whoops, okay, Unity is reloading, so sometimes the UI does that. Anyway, we want to assign our trail to this material. So we can assign a trail, so we can drag and drop it, and I'm going to drop it onto the albedo value property, and go back into our trail, and we can assign our trail material. And it's not working correctly, as you can see here, and that is because we have the wrong shader assigned to it. So the shader and material system is quite a complex one. So what I'm going to do is I'm going to click on this shader here, and let's see, particles and standard surface. I think that's what we want from our material. Okay, so let's see our material, let's see our particle again. Okay, so it's still not working, so that's actually, I'm gonna leave that as some kind of homework for you guys. So find out what kind of, why our material sprite is not working with our particle system, and we will see, and we will resolve it in the next workshop. Now we also have the sorting layer, right? Because it's a 2D like effect, so Unity also need a way to display it like one on top of another. So we want to set our sorting layer, and I'm gonna set it to background, but the order will be 1. So it will be below our player, but it will be on top of the background because the background ordering layer will be 0. So now that we have a trail, and we need to make this trail follow our player as it moves around in the screen, right? And well, if we assign a trail like to our player, make it a child object of a player, that will not work. So if I hit play here, play, and we can see that the trail does not play when we when we move our player, although the trail actually moves because our player moves. It doesn't like play the actual particle itself. Why is it taking so long? Alright, so if we move our player now, we can see that there is no actual sort of trailing effects. And we go into our scene, we don't see it. And that is because our trail sort of effect moves independent with our player, right? Moves independently. So we have to go to make this like not a child object of player anymore. So if I drag trail and I drag it out of a player, I can like reset it and not make it a child object of our player. And what we have to do with our trail here is we have to move it through the script, through a script. So to set its position to always follow the player, right? So in our scripts folder in the project panel, right click and create a C# script. And I'm just going to call it trail follow. And it's going to create the script, going to compile it, and if I go back to my editor, I can see we have a trail follow script. And this script will be very, very simple because we only have one job here, which is to make our trail follow our player, right? So it will be very, very simple. I'm just going to make a reference to our player. So public transform player. Yep. And we always want the trail to follow the player. So in the update method, we just say transform position, which is the current position of the trail particle effect. And we just want to say is equal to player position. Just like that. And that is everything that we need for the trail follow script. So go back to Unity. So now we need to add the component to our trail object. So we need to add this trail follow script to our trail object. And we can do that by dragging and dropping onto the inspector. And it's asking for a player transform. I assign my player, dragging and dropping it, and now it will work. So play, let's see. So now when I move my player, we see that there is this trailing effect here, and yeah, the trail now follows my player. It looks weird because we have the incorrect materials assigned to it, but in the next workshop we're going to be fixing that, making our trail looks very cool. And so the next sort of thing that we want from our game is whenever we click with our mouse, the player will start shooting like bullets, right? So yeah, so we're going to be handling like the bullet object. We have to create a bullet object and the bullet shooting functionality in our next workshop. So that will conclude this workshop. If you have any questions, concerns, yeah, just ask us, and I will see you next week.